Okay, class, what we're going to go through today is finishing up exponential growth and decay with what decay is. And so the warm-up I'm not gonna go through, but just what do you notice? I mean, the initial amount is the same on all of these. And then what's changing is this would be a growth, this would be a 36% increase. This would be a 50%, right, decrease, or you're going to get 50% of what you started with on the second one. And then this guy, here you're keeping 50%. Here you're going to be actually keeping 81%. And that's pretty much what we're going to be looking at in this video is how we got 81%. So, and if we kept 81%, then what technically is our exponential decay. Like, what's the percent that we are losing per whatever this time frame might be, which in this case would be about 19%. So that's what we're going to look at, and so let's get into it. Exponential decay. It's very simpler. It's very simple. It goes very similar along with exponential growth, where you have the 1, and we drew that percent box. So I'm going to show you that in a second. But now instead of adding a percent to it, we're going to be subtracting our percent away from it, and it's going to make a little bit more sense on this next slide. We'll look at it. So the increase versus decrease. Before, in the previous lesson, we talked about if we had like a 15% increase, what would happen is we would still get 100% of what we started with, but then we would go up 15%. And then we would have a total then of 115%, which would turn into 1.15 for a rate. So if you had 4,500 and you had a 15% increase, your rate that you would plug in would be 1.15 based on it you having 115% of it. And then you'd obviously have your time, your exponent. And so now what we're doing is very similar, but it's going to be decay. So we're going to go down, and let's just change it and make it the opposite. Change color here. Let's say we have a 15% decrease, right? Decrease or 15% decay. And we'll keep that same idea. You have a $44,500 car, and it's going to decrease in value every year by 15%, we'll say. So what we're going to have is the 100%, right? This is the total value of your car right here, represented by this block. This is 100% of your car, $4,500. Every year you're going to lose 15% of that, which means you are now going to go down 15. You're going to lose 15%, which will put you at 85% now. You're going to get to keep 85% of your vehicle's total value every year. So at the end of year 1, what you get to keep is 85% of that vehicle's value, because you're losing 15%. And so now this is going to be our new rate. We're going to put that as a decimal, which is 0.85. So we have 0.85 like that. Right. And another way you can look at this is using this equation. This 1 is really similar as 100%. And then you're going to subtract your percent they give you, your percent decrease. So in this case, it's 100% minus the 15%, which gives you 85%. And then just remember that you can't plug 85% into the equation, and that actually has to be a decimal. So then you'll get 0.85 for your equation. So that's another way, if you don't want to draw the picture, and just remember you're subtracting 15, or you're subtracting your percent from your total. And it also worked in the reverse. If you don't want to draw the picture to show like, hey, well, we're going up 15, in problems that are growth problems, the only thing that changes is this sign right here in the middle. It becomes a plus. So really, no matter what, every problem, you're always starting with 100%, and you're either going to add your percent to it or you're going to subtract your percent from it. And then that'll give you your new percent, which you convert to a decimal. And that's pretty much the lesson. So if we're looking at these problems right here, your initial amount, you can go ahead and pause the video and try to answer these questions. But this first one is 200 for your initial amount. Your decay factor is just 0.25, which is what is in the parentheses. So your percent decrease, now this is where it's kind of interesting, is you get to keep 0.25, so you're keeping that much. So you started out at having 100%, right? It's creating this visual so you can kind of see it. And now you subtracted a certain amount, but we don't know what that is yet. So much that when we converted it to a decimal, it was 0.25, right, is what we were left with. So we got to kind of ask ourselves, well, what is 0.25 as a percent? When you multiply that times 100, you'd find out that it's 25%. So really what we're doing is we're keeping 25% of what we started with. And so if we're keeping 25%, the question then becomes, well, what did we then lose? If you do the math on that, you've lost 75%. So your percent decrease is 75%. All right, let's try this one. What is your initial amount? Go ahead and pause the video. If you'd like, you have 1,000. Your decay factor is 0.7. And your percent decrease, so since our percent decrease, what we're keeping 0.7, or 70% is what we keep. Right, so if we're keeping 70% out of the 100, so we are at 100%, we get to keep 70%. So what did we subtract? Well, we subtracted 30% from that. So our answer here would be 30% decrease. Sorry, I kind of made it look like this was your answer, but you're keeping 30% then. Here's a car depreciation value, so we'll do this last problem and then we'll call it good. I'm going to pull up a calculator. Give me 1 second here. So a brand new Corvette 2022 is $91,180. And if it loses 11% of its value as soon as it gets titled, then what is it going to be worth after it's titled? So we're kind of ignoring this part right in here and this part right here for this question. So it's going to lose 11%, which is a true story. It loses a lot of its value once it switches titles. But so our initial value is 91,180. That's going to be a decay. Now it's going to lose 11%, right? We don't get to keep 11%, but that's what we want to figure out, is that we are at 100%. We are going to lose 11%, which means we are going to keep 89%. Okay, so that means our rate then can't be a percent, so we're just going to move it into a decimal, so it's 0.89 t, which in this case it's only going to happen one time. So let me see if I can get a calculator. Sorry, I don't have this pulled up, so I got to go to Desmos quick and type this in. And we have 91,000. We're going to type it in exactly how we see it, 91,180, parentheses 0.89. And we will have a value, once it gets titled, at being $81,150.20. Okay, now let's look at this next part. And first, I'd encourage you again to pause the video. Give this a shot. Try to solve this one. Even if you get it wrong, no big deal. But we're now focused on it losing 15%. And how much will it be worth after 6 years? So if we're losing 15%, we are starting with the initial value of 91,180. We're looking for our rate. We're going to have it to the t exponent, which is actually in this case is going to be 6. And so we have to figure out what our decay value is going to be. So we're starting at 100% if we think about it without using the boxes. We're going to subtract 15% each year, which means we're going to get to keep 85% every year. And in our equation, we can't use a percent. So we just got to convert that back to a decimal, so we have 0.85. If we type this guy in, we will get sorry about this. It'll be worth $34,388.49. So there's a couple of examples on problems, and we can go back and rewatch these. If you have questions, make sure you come find me, but that is exponential decay, very quickly put. See ya.